Hey guys, Angel here. And so question 8 asks, which of the following statements are true for the compound cis-1,2-dichlorocyclopropane? And so one of the things we're going to want to notice right away about this compound when we draw it out is that it has an internal plane of symmetry. And so that makes us want to start thinking towards the fact that could possibly be a meso compound. But besides an internal plane of symmetry, we also need to make sure that a meso compound has a minimum of 2 stereoisomers with different absolute configurations at each side of the internal plane. And so looking at this carbon here, we've got a chlorine. We've got 2 carbons before reaching this next chlorine, 1 carbon before reaching that same chlorine, and then a hydrogen. So that is 4 different things, and so that would be a stereoisomer, a stereocenter. And so we'll check on that one and check on that one. So we do indeed have a meso compound. Okay, so now the option A asks or states this compound is chiral. Well, what do we know about meso compounds? And question 2 of this playlist goes a little bit more in depth about meso compounds. But meso compounds are achiral, meaning that they are superimposable. They are superimposable on their mirror image. If they were chiral, they would not be superimposable on their mirror image. And so let's go ahead and actually draw the mirror image out. And so when we draw the mirror image, we see that these are actually identical. And so the fact that they are identical is what makes them superimposable on one another. Their mirror images are superimposable. If these were chiral compounds, they would not be superimposable. And so A is out, meaning that D is also out. Okay, so it is not chiral because it is superimposable on itself, on its mirror image, I'm sorry. Okay, B, the enantiomer of this compound is trans 1,2-dichlorocyclopropane. Okay, so we know that cis and trans are actually diastereomers, and so we've got cis here, so trans would actually be the diastereomer, so that is out. So cis and trans are always diastereomers. That does not mean that diastereomers are always cis and trans. Okay, next we've got this compound contains no asymmetric carbons. Well, that can't be true because we determined that this is a meso compound, and a meso compound has to contain at least two asymmetric or stereocenter carbons. And so that is also out. And so that leaves us with none of the above.